It's because you can actually see the rise and the run. You can actually see the rise and the run and measure them in feet. But sometimes you can't. For example, while you guys were dutifully calculating your grades, I went down and I measured an ADA walkway with my transit. And the trick with that one is, it's a smooth diagonal. I couldn't get the rise and the run both. I could only get the rise using the measuring stick that goes out to 8 feet on the ground, extended out, with the transit. And the only other thing I could get was the hypotenuse, which is the part you actually walk along. With me so far? Mm-hmm. So let's come over to here and show you what I'm talking about. Let's suppose this, remember this diagram of College Way? We're going to change it. Well, we could, but I think I use it the way it is too. I'm going to pretend that triangle represents the ADA walkway. Erase some of this stuff. Okay, take all those numbers out. Okay, numbers gone, run. Actually, the rise and the run is fine. Hypotenuse. Now, the reason I care about this is ADA walkways have to have no more than a certain grade by code. They can't be poured any willy-nilly, however you have. That's why you've seen sometimes ADA walkways spiral around a lot. That's to pick up enough run to actually make the grade drop down to be accessible. Fair enough? So I want to check this one to make sure it was done right. Michael?
The one in front of MODOC?
Yes, the one in front of MODOC is a great example. The one in front of Pioneer, the new one in Pioneer that zigzags back and forth across that hillside is a great example of that. We're just not close enough to that one to get you guys to walk to. So let's check the grade on this one. And then if we have time, we'll go into Google and see what ADA code is and see if we match it or exceeded it. So here's the numbers I know. I know the hypotenuse was 27 feet 4 inches. That's the actual walkway itself, 27.4. The rise, 7 foot 5.5 inches. The question I have is, what's the grade? What's the grade? Good, stunned silence. Because why? Because we don't have the run. So the question I have is, can we get the run? Hell yeah, we can. What's the relationship between the rise, the run, and the hypotenuse? Do you remember? It starts with P. That's the one. I was going to say it ends with Pythagoras, but you got it. It's the Pythagorean theorem. Remember what it is? Don't you dare say A, B, and C. Don't you! What did I just tell you, boy? Don't use A, B, and C. No, it is A squared, B squared, C squared. But the reason I don't like that is because students forget what A, B, and C are. Pythagoras says that the hypotenuse squared is equal to the run squared plus the rise squared. That's what Pythagoras says, and I like it that way. Yeah, it's harder to say.
So you're going to minus the rise from the hypotenuse.
Yes! We need to find the run, correct?
Yes.
We need to find the run, which means I got to bring the rise over here. I'm going to do this algebraically first, if it's okay with you guys.
Yeah.
Hypotenuse squared minus rise squared equals run squared. Now, careful. This is also going to help you in your project that's due Wednesday. I want to take the square root of both sides. If I take the square root of both sides using a different color, maybe, yes. Here, it cancels out this one, right? There. Yeah. This now becomes run. What trick question? What does this become?
Square root of hypotenuse.
I love it. Nothing changes. It's still that. You cannot cancel those squares with the radical because it has a subtraction sign in there. If you need more explanation, look at the project that's due Wednesday. It breaks it down for you. So now I can figure my run out because I have the hypotenuse and I have the rise. It just takes a little bit of TI work at this point, huh? A little bit of TI work, which I will now do. Did anybody have my calculator?
It's right here.
Oh, awesome. Thank you. Let's figure it out. Let's figure it out. Everybody, if you're not okay with that, like I said, just the project due Wednesday will definitely help you understand why you can't. It's order of operations. What's up, Di?
I'm curious as to what happened to the squared on the run when you put it, the radical.
It undoes the square on the run because the radical undoes the square. But the problem is there's an order of operations that's not being observed.
Why wouldn't it take off the hypotenuse too?
That's what I said. Look at that project due Wednesday. It's an old algebra skill that you learned back in Math 60 or Math 65 and probably have since forgotten. Take a look.
Could you figure out hypotenuse and rise squared first and then do?
Yes, of course you could. I'm going to go in one spot right here, Nick.
Okay.
Here's the other reason too. Well, we'll come back to that. We'll come back to that. I want to calculate this number. All right, so I'm going to do this all at once. This is going to be a big TI move. I'm going to do it all at once. Don't get too freaked out with it. Square root, okay? The hypotenuse is 27 feet, 4 inches. Now remember, there are 12 inches in a foot. So see if you buy this. I'm going to add 4/12. Because 4 inches is 4/12 of a foot. You see what I just did? I turned it to a fraction to make sure it's legit. And I'm going to square that. That's the hypotenuse squared. Minus. I'm going to do the same thing with the rise, which is 7 feet plus 5.5 over 12 feet. Square that. Okay, so that's the hypotenuse squared is right here. And the rise squared is right here. And I subtract them. That's the whole pesky problem right now, is that subtraction. That's why we can't break the radical down. I'm going to close the parentheses off because I'm a good math dude. Boom! That is how much it runs. Roughly 26.3 feet. 26.3 feet. Now, I want to re-answer Linda's question. Why is it that the radical doesn't cancel the squares on the hypotenuse and the run? Pretend it did for a moment. Pretend it did for just a moment, okay? If it did, that would mean that the run plus the rise equals the hypotenuse. If they canceled. Because if they canceled, you'd have hypotenuse minus rise equals run, which would mean that run plus rise equals hypotenuse. That can't be true. Because if the run plus the rise equaled the hypotenuse, you wouldn't even have a triangle. Here's a hypotenuse.
I think the thing I'm getting confused about, because even in 95, when you have a square or root over the two that are, it cancels them out.
Not if they're subtracted or added. If they're, you have to observe order of operations.
Okay.
Don't think Math 60, 65. Think logic right now.
Okay.
Here's a hypotenuse. Can this plus this ever exactly equal that?
No.
The only way that could be true is if they were laying on top of it. They have to be added together bigger than that. But if you cancel the radical, it's going to create an impossible situation. And look at our numbers now. Is this plus that bigger than that? Yes, and we wanted it to be because it has to be bigger than that, doesn't it?
Right.
It has to be because it's a triangle. It's called the triangle inequality in mathematics. Don't memorize that or anything, but that it needs to be. It has to be. Except a flashback, I apologize. Ready to do the grade?
Yeah.
Let's do it, because now we have the numbers we need. We've got the, watch this fanciness. You ready for this? I can do 7 plus 5.5 over 12. That's the rise, correct? And then I can do divide by, now I can type all that number in here, or here's something you may have learned in your previous classes. If you press second and the negative sign, it copies that last number down.
Oh, I didn't know that.
It's okay, that's why I like doing this in class. If you hit second and the negative sign, it says ants, which means it takes the answer from your last calculation and copies it down. Of course, with the amount of time I just said that, you could have also typed it. But, now you know. Now you know. Ready for the grade?
Yeah.
What is it?
26%.
28% grade. I'm going by memory here. I'm going by memory. I think it's a 1-4 grade. Oftentimes, when they lay concrete and roofing, they talk about it in 12-12, 6-12, things like that. I think it's a 3-12 or 1-4 grade. 1/4 would be 25%, 0.25. That's damn close to 25%, and you got to remember, I was taking the measurements, which means there's error in my measurements. I'm going to find out, because we're out of time. I'm going to call Gene Zingraf, good buddy of mine, who I think actually laid those. He was the foreman on the job. We're gonna ask him what code is. We're gonna let him know what our calculations were. We're gonna see how it comes in. Yeah?
Yeah.
There we go. There we go. Your job for next time?
Project?
You have a project, yes.
Project and quiz.
I am going to push the quiz back. Here's the deal. Here's the deal. I can't assign 3 things at one time. That's just cruel and unusual punishment. You have a project due. Yeah, got a project. I want you to keep doing that. You're probably already working on it anyway. I want you to knock that out. Especially because it'll help with this mathematics right here if this wasn't completely clear. There was a quiz due. I also want you to do the grade homework. Let's push the quiz back and give you an option to turn it in next Monday if you want to. That way you don't have 3 things due in one day, which seems a little excessive, doesn't it? Yes.
So our grades homework.
Do the grade homework for next time. So we've pretty much done enough of that here.
Right.
And the project, which it sounds like you guys have already started on, and I'll give you an option to turn in the estimation quiz next week if you want to. Of course, you can turn it in Wednesday if you want, but optional, turn it in the next week as well. Is that fair? That way you don't have 3 things due in one day. It's kind of ludicrous. As far as quizzes though, turn in this quiz for sure. Make a little pile right here. Make a little pile right here of the in-class quizzes. Let's give you all 10s on those. Yes? Yes, that's what I'm saying.
No, I'm.
We'll see you guys on Wednesday.
I'm happy. Thank you.
Rock on, it's gonna be good.
Thank you.
This was good. Oh, that's I can make them, sorry.
Yeah,